All right, so here's part two, application problems. These should be pretty easy for you. Before we even begin, I already pre-drew the triangles to kind of show you what I was looking at. You'll need to do that whenever you do these problems. First thing you'll want to do is draw the actual triangle. Taking a look here, if you line up your eyes with a horizon and tilt your head up, it's what we call the angle of elevation. If you tilt your head down, it forms an angle of depression. They're equal, believe it or not, because of the fact that you're looking from 90 degrees to start. Okay, so if you look straight ahead um, and then you were to look straight down, clear down to your feet, that would be 90 degrees. Or if you were going to look straight up, right up on top of you, that would also be that you were making a 90-degree angle. So anytime that you go down or up from there, it's going to produce the same type of angle within. So here are a couple of problems that I have for you to try. Again, if you want to, you can always screenshot these, pause the video and screenshot them, or maybe just take a picture and kind of see how they're done. The height of an observation tower is 30 feet. A ranger at the top of the tower sees a fire along a line of sight that's 1 degree angle of depression. How far is the fire from the base of the tower? If you notice that 1 degree, that angle of depression, okay, it's going to be the same as an angle of elevation. So down here is actually where I'm going to have 1 degree. So how far is the fire from the base of the tower? I'm going to be looking at where this is located. So I'm going to plug that in. I've got my opposite and my adjacent. So I'm going to use the tangent of 1 is equal to 30 over x, or x is equal to 30 over the tangent of 1. Which is going to give me 1,718. I'm just going to do 2 decimals, which actually rounds to 0.70 feet. Oh, it says round to the nearest foot. I apologize. It says round to the nearest foot. It actually gave us something this time. So I'm going to say 1,719 feet. Next example here, suppose a tree 50 feet in height casts a shadow length of 60 feet. What is the angle of elevation from the end of the shadow to the top of the tree with respect to the ground? This one doesn't make me round, so I'm going to do 2 decimals here. Once again, I've got my opposite and my adjacent, so tangent theta is equal to 50 over 60. Theta is equal to inverse tan of 50 over 60. So theta is going to be equal to approximately 39.81 degrees. Commercial airline pilot is flying at an altitude of 6.5 miles to make a gentle descent for landing. Descend towards the airport when still fairly far away. Pilot begins descending 186 miles from the airport. What will the angle be that the plane's path makes with the runway? This is very similar to what we just did. We're going to have the tangent of theta is equal to 6.5 over 186. So theta is equal to inverse tan, 6.5 over 186. So theta is going to be approximately 2.00 degrees. And then if the plane's path is to make an angle of 5 degrees with the runway, how far from the airport, measured on the ground, must the pilot be descending? So now we're trying to find that length, that adjacent side. So tangent of 5 is equal to 6.5 over x, where x is going to be 6.5 tangent of 5. Now, I'm a trained teacher, I hope. I know what I'm doing for the most part. So if you are like, wait a second, I need to slow down, Mr. Stewart's going too fast, can you just back up a little bit? Remember, you can always rewind. You can always pause this video beforehand. This is 2930, and then that would be miles. You can always pause the video and go back to it. Two more examples here that we've got. A telephone pole is broken in a storm, top of the ground, 30 feet from the base of the pole. The angle the top part of the pole makes with the ground is 35 degrees. How tall was the pole before it got damaged? So tangent 35 is equal to x over 30. So 30 times the tangent of 35. Round to the nearest foot, 21 feet. And last here, an engineer stands 50 feet away from a building, sights the top of the building with a surveying device mounted on a tripod. The surveying device is 5 feet above the ground. The angle of elevation is 50 degrees. How tall is the building? So we're already 5 feet above the ground, so we've already got 5 feet of height on that building. We need to figure out what the rest of that's going to be. So I'm going to use the tangent of 50 is equal to x over 50. So then x will be 50 tangent of 50. It's going to be, when I round, that's approximately 60. And then I'm going to add that extra 5. So that building is approximately 65 feet. And that's all for this video.